To do one, first decide what you're going to put on the X and Y axis. We'll put the time of day on the X, so morning, noon, and night. And we'll put the temperature on the Y axis. If you put 0 in the middle, I saw a lot of people do that, 0 degrees, and then positive numbers above it and negatives below it, that would be okay. 1, 2, 3. Put temp. So all you need to do is show that the temperature was below 0, went above 0, and then went back below 0. Let's label the X and Y axis in number 2. We'll put time in days on the X axis and the miles on the Y axis. So let's see, he traveled 50 miles the first day. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we'll label the days. And the miles, it looks like, need to go up to 100. So if we count by tens, we'll be good. 40. Okay. So let's jot down that on day 1, he went 50 miles. So I'll plot that, 150. And then the next week, so over the next 7 days, so 7 days went by, that would bring us to day 8, he covered 30 miles. So that will bring us to 880. So I'll plot that, 8 over 80 up, right there. And then he finished the race in the next 2 days. So 2 more days went by. That would bring us to day 10. He finished the race, which was 100 miles. So we went 20 miles in those last 2 days. So we'll plot 10, 100. Now we'll just connect those with a line. So starting at 0, 0, you have to start there because at the beginning of the race he hadn't gone anywhere. So the graph should look like that. We need to fill in the table first to show how far the swimmer has gone. At 0 seconds, the time will be the x-axis, and the distance will be the y in feet. So at 0 seconds, the swimmer swam 0 feet. After 1 second, he swam 2 feet. After 2 seconds, he swam 4, and then 6. So the change in y, this is going up 2 every time the x goes up by 1. So the change in y over the change in x for the slope is 2 over 1 or 2. So that's the slope. The y-intercept is 0, 0. So our equation is y equals 2x plus 0. So we'll put the time on the x-axis, the distance in feet on the y, and I'll count by 2s, 2, 4, 6, 8. I'll just plot those points, 0, 0, 1, 2, 2, 4, and so on. So the line looks like that. Alright, here are my hints for the piecewise graphs. First, let's fill in all the y values. They're all going to go in this first column. The y's come from the y-axis. So let's look at that first number right there. It's 0. The next number is 2. And then it goes up to 5. And then 8. Okay, so you get half credit just for filling in those numbers correctly. Next, let's figure out the x intervals. So now we're going to look at the x-axis for where these lines are. This first one is between 0 and 3. So I'm going to put the 0, I'll put the 3, the x in the middle, and I'll make the signs point to the left. Since the end one on the left here is included, I'll put the equal sign, and since that's an open circle on the 3, I'm going to leave it. I'll do the same thing with the next step. It starts at 3 and it goes all the way up to 8. So 3 is the low number and 8 is the high number. I'll put the x in the middle. I'll make the signs point to the left, and the end point on the left gets the equal sign. The one on the right does not, because it's open. Same thing with the third step. It goes from 8 all the way up to 18. That's that number right there. So 8 to 18, x in the middle, and the signs will be the same as they were right above it. And then the last one, I would accept if you put either between 18 and 20, if you did it like this. Or I would accept, if you weren't sure if that kept going or not, that if you put 8, or x is greater than or equal to 18, I'd also accept that. For number 5, let's figure out where these x's fit. So where does negative 10 fit? Is it less than or equal to 0? Yes. So we'll use 2x plus 1, but that's not the final answer. We have to take the negative 10 in, plug it in for x right there. So the answer will be 2 times negative 10 plus 1, which is negative 19. Now let's see where the 2 fits. Is 2 less than 0? No. Does 2 fit in between 0 and 5? Yes. So we use 8 for the answer. Since there is no x, we do not need to plug the 2 in, and we're done. Now let's try the 5. Is 5 less than 0? No. Is 5 in between 0 and 5 but not including 5? Nope. But is 5 greater than or equal to 5? Yes. So we'll use the x plus 1, but that's not our final answer. We take the 5 and plug it in for x. So the answer here is 6. Alright, remember how I always point to the first column and say those are your y's? Let's draw those. Let's go up 2 on the y-axis and draw a line all the way across. But now we're going to cut it off at negative 2 on the x. So on the x-axis, here's negative 2. Alright, so I drew that line, and we're going to keep everything to the left of the blue line. So I'm going to erase everything that's not on the left side of that blue line, and I'm going to put an open circle. Alright, now I'll plot the line at negative 4, so I'm going to go down 4 and make a line. And this time it says we have to keep everything that's greater than negative 2. So I'm going to keep everything on the right side, and since that has an equal sign, I'm going to put a closed circle. You do not need that blue line as part of your answer. I was just trying to show you where the cutoff was for where the lines start and end. So that's the answer. Alright, let's add f and g together. So we're going to have 5x squared plus 8x minus 2. We're going to add to it negative 2x plus 3. Make sure you copy the problems down right. I've seen lots of people get things wrong just because they copied things wrong. So we have parentheses with a positive 1 in front. So basically, we don't really need those parentheses. And look at the second set of parentheses. They also have a positive 1 in front of them. That's not going to change anything on the inside. So we basically don't need those parentheses either. So what we're going to do is just combine like terms. So 5x squared, those are the only x squareds around. Now let's put the x's together. We have plus 8, and it's going to be plus a negative, or just minus 2x. So 8 minus 2 is 6 x's. And last we have negative 2 plus 3, which is positive 1. Now let's do the subtraction problem. So I'll write down 8x squared plus 6x minus 2. We're going to subtract negative 10x plus 5. Alright, in front of the first set of parentheses, nothing is going to change what's on the inside. But this negative 1 right here will change the signs after it. So this is going to change to plus 10x, and that 5 will change to minus 5. Now we can combine. Looks like I only have 8x squareds. I have 6x's here and 10 more here. So that's 16 x's. And last, negative 2 minus 5 is negative 7. To multiply these two together, see how that's a multiplication problem? I'm going to draw parentheses around them, but you know I like doing the box method for 2 by 3s. So I'm going to go ahead and set up the 2 by 3 box. So negative 5x and positive 9 go on the side, and then the 2x squared, the 8x, and the negative 6 go on top. So we should have negative 10x to the third, negative 40 x to the first times x to the first is x to the second. Negative 5 times negative 6 is positive 30 with an x. If you got this one wrong, it's probably just because you multiplied or combined like terms wrong. So 9 times 2 is 18x squared. 9 times 8 is 72x. And 9 times negative 6 is negative 54. Now we'll go through and combine like terms. So I have negative 10x to the thirds, and that's it. Next, we can put these together. So that's negative 22 x to the seconds. We can combine these, and we get 102 x's, and last we have the negative 54. The first thing we'll do in number 10 is write the f function on top and the g function on the bottom. So now we need to factor. Let's look at the top. Number 1 rule is to see if we have a GCF we can divide everything by. And that number in this case is 2. When you divide 2x by 2, you're left with just x. And when you divide 4 by 2, you're left with 2. Now let's take care of the bottom part. Let's look for a GCF. You can divide both of these also by 2. So don't forget to write it. And let's write the leftovers when we factor it out. So it's going to be x squared and minus 4. So if you notice, we can cancel out those 2's. We have that one factor, the x plus 2 on top. But what about the bottom? That one's not all the way factored yet. See how it's x squared? That means that we have 2 factors that multiply together to get that. So we have to find the factors of 4 that subtract to give us nothing in the middle. So those numbers will be 2 and 2. 1 positive and 1 negative. Now, the last step is to cancel out the x plus 2's. And since there wouldn't be anything left on the top, we'll write a 1, and then we'll put the x minus 2 underneath it. Now number 11. Let's start and work from the inside out. So pay attention to which one you have to use first. We have to use the f function first. We're going to plug 3 into the f function. So the f function is x to the third. So we have to figure out what 3 to the third is. It's 27. Now we're going to take that and plug it into the g function. So g of 27. So the g function is 2x plus 9. We'll plug the 27 in. We'll get 2 times 27 is 54 plus 9, and our final answer will be 63. All right, number 12 will be kind of similar. Let's start with the inside, f of 2. So into the f function, we're going to plug 2 in for x. So it's going to be 2 to the third, which is 8. We take that and plug it into the g function, so g of 8, which means we have to plug the 8 in to this for x. So that will be 5 times 8 plus 6, which is 40 plus 6, or 46. To figure out if the inverse of a relation is a function, you do the horizontal line test. Since a horizontal line crosses that twice, the answer is no. The inverse is not a function because it fails the horizontal line test. Number 14, let's rewrite that using y equals. Now we'll switch the x and the y, so it'll be x equals 2y plus 12. And now we'll solve for y. Get rid of the 12 by subtracting. So x minus 12 equals 2y. Divide both sides by 2. Divide everything by 2. And the final answer will be, see how there's a 1 in front of the x? That's going to give us 1/2 x. And now negative 12 over 2, that's minus 6. Last question, and I know a lot of you ask about this, and I don't exactly blame you. So I'll walk you through it again. First, let's figure out f of g of x. So into the f function, we're going to plug in the g of x function. So 7x minus 42. So let's write down what the f function is. It's 1/7 x plus 6. So let's take that red part and plug it in for that x, which means we need to copy the 1/7 and then inside parentheses put the 7x minus 42 and then the plus 6. So now we will distribute. 1/7 times 7 is just 1, so 1x. 1/7 times negative 42 is negative 6, and then we have the plus 6 out there. So when you put those together, they equal 0, and we get plain old x for the first way. Since we got x, we need to keep going and compose it the other way, g of f of x. So into the g function, we're going to plug the f of x function. So it will be g of 1/7 x plus 6. We have to plug that into the g function, which is 7x minus 42. So we'll take the blue part in parentheses and plug it in right there for that x. So we have the 7, and now in parentheses we're going to have 1/7x plus 6, and then the minus 42. So let's go through and distribute. 1/7 times 7 is just 1. 7 times 6 is 42, and then we have minus 42, and when you combine those, they cancel out, and you get 0. And so since we got both of the compositions to equal x, we say yes. This problem shows two functions that are inverses.